Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique line is the one which happens to be inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. Now since this line happens to be inclined to both HP and VP, so neither of the front view or the top view they will be parallel to the XY reference lines, and the projections of the line on the horizontal plane as well as on the vertical plane will reveal its apparent length only, and we are not going to obtain the true length of the line in the front view as well as in the top view. So we need to apply the principles of rotation of the line in order to obtain the true length of a line. Now here we have been provided with a physical real life environment situation in which we are going to convert this real life situation into the projections of the oblique line, and we will be determining the true length of the line using the principles of rotation of the line. So here we have got a room which is having the dimensions 5 meter as the width of the room. So this is the width of the room which happens to be 5 meter. Then the depth of the room happens to be 4.5 meter and the height of the room happens to be 3.5 meters over here. Now we are required to graphically determine the true length of the distance between top right corner. So this is the top right corner. So this will be joined with the diagonally opposite bottom left corner over here. So this point which we have named as point A, and this is the point B, right? So we are required to determine the distance between this point A and this point B. So point A happens to be the leftmost point which is available at the bottom of this particular room, whereas point B happens to be the rightmost top corner of this particular room. So here, by using the principles of the projections of the oblique lines, we are going to determine the shortest distance or the true length between point A and the point B. And we must remember that these 2 points, so they form the length of the string which is going to join these 2 points which are lying in the diagonally opposite corners of this particular room. So in order to draw the projections of the oblique line, first of all we need to convert this situation into the projections of the oblique line. So here we can see that when we are going to look at this particular room from the front side, the front view will be available with us in the form of the width of the room and the height of the room. So width of the room happens to be 5 meters, whereas the height of the room happens to be 3.5 meters. So here we are going to use the scale as 1:100. That is 1 meter length or the width of the room we are going to take as 1 centimeter, that is 1/100 scale. So this will be equal to 10 millimeter. So the width of the room will be represented as 50 millimeter. Since the width of the room happens to be 5 meter, so using the scale of 1:100, so we are going to draw the width of the room equal to 50 millimeter. Similarly, we are going to get the depth of the room equal to 4.5 meters. So this will be drawn as 45 millimeter into the orthographic projections which we are going to draw over here. And finally, the height of the room happens to be 3.5 meters. So the height of the room will be represented as 35 millimeter in the orthographic projections which we are going to draw over here. Now in the front view we are going to view the width of this particular room as 50 millimeter and the height of the room equal to 35 millimeter. So the front view of the room will be drawn as 50 millimeter by 35 millimeter. Similarly, in the top view, you see what we are going to see in the top view. We are going to see the width of this room, which is again equal to 50 millimeter in the top view. And besides the width, we are also going to work out the depth of this room, which is corresponding to the depth of 4.5 meter over here. So the depth of the room will be 45 millimeter. So the top view, which will be represented by width and depth of this room, will be represented as 50 millimeter by 45 millimeter. So this way we can convert this physical real life problem into the projections of the oblique line problem, whereby in the front view we are going to draw the dimensions 50 millimeter by 35 millimeter, whereas in the top view we are going to draw the dimensions of the room as 50 millimeter by 45 millimeter. And using this particular information, we are required to draw the projections of the line AB, that is the front view A dash, B dash, and similarly the top view of the string, that is AB. So this we are going to draw in the orthographic projections, and thereafter we are going to use the principles of the rotation of the line method to evaluate the true length of the line AB in the front view as well as in the top view. And finally, we will be evaluating the inclination of this true length, that is theta and 5 angles with the horizontal plane and the vertical plane over there. So let us start with the construction of the orthographic projections of this particular room. And once we draw the front view and the top view, we are going to obtain the apparent lengths which will be visible to us in the front view corresponding to the points AB, that is A dash, B dash, and similarly we will be able to obtain the apparent length of this particular shortest distance or the string joining points A and point B, that is small a, small b, in the top view. So let us start with the construction of the orthographic projection. So as we have discussed, the front view of the room will be having the dimensions 50 millimeter by 35 millimeter. So it is this front view that we are going to draw, width and height of this particular room. So the width happens to be 5 meter. Corresponding to this, we are going to draw the width as 50 millimeter over here. So we can please check. 50 millimeter, it is the width of this front view or this room, and the height of this particular room, it is equal to 35 millimeter or 3.5 meters over here. So this provides us with the front view construction corresponding to this particular room. And as we can see, point A, it lies in the leftmost bottom corner of this particular room. So corresponding to this point A, in the front view, we will be able to obtain point A dash over here. Similarly, point B, it lies on the rightmost corner of this particular room at the top portion over here. So this point B, it will be projected over here as we are going to look at this particular room from the front side. So this point B, it will be projected over here, and we will be getting point B dash in the front view, which will be located at the topmost corner of this particular front view. So this way, once we join A dash with B dash, so we will be able to obtain the apparent length of this particular shortest distance or the string, which is going to join these two oppositely located diagonal corners of this particular room. Now let us start with the construction of the top view. So in the top view, we can see over here, again we are going to get the width of this room as 50 millimeter, that is equivalent to 5 meter at a scale of 1:100. So we are going to get the width, it is equal to 50 millimeter, and besides the width, we are also going to get the depth of this room, which is equal to 45 millimeter. So this is the depth of the room over here. So this 4.5 meter will be converted to 45 millimeter with a scale of 1 by 100. So the top view of the room will be a rectangle having the width equal to 50 millimeter and the depth which is equal to 45 millimeter. So this is the width 50 and this is the depth equal to 45 millimeter. Now as we look at this particular string, so here we are going to get point A. So point A will be projected at this particular corner over here in the top view. That is, this point will be representing top view corresponding to the point A. This point A, we can again see it will be converted to this point A over here, small a over here in the top view. Similarly, point B. So the top view corresponding to this point B will be located over here. So this way, the top view corresponding to this point A, it will be located over here. This point B top view will be projected at this corner. So once again, we can join these 2 points A and B and we will be able to obtain the apparent length corresponding to the string which is going to join these 2 opposite corners of this particular room over here. So the front view has been obtained as A dash, B dash, the top view of the string which has been obtained over here as AB. So once these 2 apparent lengths they have been obtained in the front view and the top view construction corresponding to this particular room, now we are left with evaluation of the true length of the distance which is going to be joining these 2 diagonally opposite corners, that is point A and point B, using the rotation of the line method. Now using the rotation of the line method, we are going to observe that whenever the apparent length of the line, that is A dash, B dash, it happens to be parallel to the horizontal plane, so on the horizontal plane in the top view we will be able to obtain the true length of this particular line over here. But what do we obtain over here in the front view and the top view? Here in the front view as well as in the top view, we have monitored that A dash, B dash happens to be inclined to the horizontal plane. Similarly, AB projection, that is the top view projection, it is also not parallel to the vertical plane. It is also inclined to the vertical plane. So here we have got a situation in which the front view projection A dash, B dash, it happens to be inclined to the horizontal plane, whereas in order to obtain the true length, we need to obtain the apparent length in elevation which should be parallel to the horizontal plane. So what we are going to do, we are going to rotate this front view projection A dash, B dash through this point A dash in such a way that A dash, B1 dash, it should become parallel to the horizontal plane. So here with A dash as the compass point, we will open the compass equal to the radius A dash, B dash, and with A dash as my center point, I am going to rotate this point B dash over here in order to ensure that A dash, B1 dash. So this particular apparent length which is rotated through this point A dash over here, and this A dash, B1 dash will become parallel to the horizontal plane. So here we can see this is A dash, B dash, which is parallel to the horizontal plane, and then from B dash we will be dropping down perpendicular onto the second point of the plan view. So here we can see the second point of the plan view is B over here. So from this point B1 dash, we needed to drop perpendicular to the second point of the plan projection. But here we have got B1 dash and B, both of them, they are lying onto the same locus line or onto the same horizontal line, which happens to be XY over here. So from here, when I drop the perpendicular from B1 dash onto the locus line of the point B, we will obtain that the second point B1, it will be located onto the XY line itself over here. So the moment we obtain that this distance happens to be 0 in this particular case. So this distance between B dash and B, that is this distance between B1 dash and B1. So this happens to be 0. Why this happens to be 0? Because point B, it happens to lie onto the XY line over here. So this way we will be able to obtain point B1 onto the XY line. So having obtained this point B1, now we need to join A with point B1 over here. So point A will be joined with point B1, and this we have drawn using a blue line. So blue line means we have changed the color over here, because A dash B dash, it was the apparent length, so which was drawn with the black color. Again AB is also apparent length in the plan. So A dash B dash, it is the apparent length in the elevation, so this has been drawn with black color. Similarly AB, it is the apparent length of the line in the plan, so again it has been drawn with the black color. But AB1, so this is the true length of the line in the plan, so this we have drawn with the blue color over here. So this is the true length of the shortest distance between the two diagonally opposite corners A and B of this particular room. So we have obtained the true length of this line or the string which is going to join these two diagonally opposite corners of this room in the top view. Now similarly we are going to obtain the true length of the string or the shortest distance in the front view as well. So in order to obtain the true length of this string, that is which is going to join these two diagonally opposite corners of this room in the front view. Now in order to obtain this shortest distance true length in the top view, now this fundamental of the rotation of the line we are going to use. So in order to obtain true length of the line in the front view, what we need to do? We must obtain the apparent length of this particular line. It should be parallel to the vertical plane over here. That is AB projection, we need to make it parallel to the vertical plane. So once the projection apparent length in the plan happens to be parallel to the vertical plane, then the projection of this line in the front view will be giving us the true length of this particular line. So what we are going to do here, we can check AB. So this is the black line over here. So AB is the projection of the string or the line in the top view. Now we need to make this apparent length parallel to the vertical plane. Now in order to rotate it and make it parallel to the vertical plane, now we need to draw this horizontal line. So this is the horizontal locus line which we have drawn. Now with A as the center, AB as the radius, I have to rotate this apparent length in plan, that is AB, and make it parallel to the vertical plane. And since this is the second rotation, so after the rotation, the name of the point which we have obtained over here, so this name will be B2. So B2 is the name of the point which we have obtained after the rotation of this apparent length black line over here. So having obtained this apparent length AB2 parallel to the vertical plane, now I need to obtain the projection corresponding to B2 in the front view. So in order to obtain projection or corresponding to this point B2 in the front view, again we have drawn a locus line starting from the point B dash, so that this point B2, it can be projected in the front view. So please check, this point B we have to project in the front view over here. So this point will be providing us with the true length of this line AB in the front view. So here from the point B2 we have to draw a vertical projector onto the locus line corresponding to the point B dash, that is the second point in the elevation over here. So here this point we will be obtaining as B2 dash. the moment we obtain this point as B2 dash, now we can join A dash with B2 dash, and again we have drawn it using a blue color line. So blue color line means we have been able to obtain the true length of this particular string. So now we have obtained the true length of this string in the top view. We have obtained the true length of the string in the front view as well. So the true length, you cannot have two true lengths for the same distance over here. So as a check, we have to measure that the true length obtained in the plan, that is AB1, should be equal to true length of this projection in the front view, that is A dash B2 dash should be equal to AB1. And once we obtain that, the distance A dash B2 dash, which is the true length of the line in the elevation, it is equal to AB1, which is the true length of the line in the plan. So once we evaluate that these two distances, they are equal, so we are sure that whatever procedure we have followed over here, that is technically correct, and we have been successful in obtaining the actual true length of this line AB, which is going to join two diagonally opposite corners of this particular room, and these are the 2 points A and B. And having obtained the true length, now the true inclinations and the apparent inclinations we need to evaluate. So angle alpha, it is the angle of inclination of the apparent length of the line in the elevation. We have measured as angle alpha. Similarly, angle theta we are also going to measure over here. So it gives us the actual inclination of the shortest distance between points A and B with the horizontal plane. Angle theta, it is the angle of inclination of the true length of the line in the front view. Similarly, we'll be evaluating the angles of inclination of the apparent length and the true length in the plan view. So angle beta, it is the angle of inclination of the apparent length of the line in the top view. So this angle beta we are going to measure over here. And finally, angle phi, it is the angle of inclination of the true length of the line in the top view. So this way we have been able to evaluate the true length of this particular line AB, and we have been able to ensure that A dash B2 dash must be equal to AB1. And once we obtain these two true lengths to be equal, it means that the procedure that we have followed in order to evaluate the true length of this particular shortest distance between the diagonally opposite corners is correct. So this is all for today. So I hope that through this discussion you would have understood about the mechanism how we can convert the real life situation into the orthographic projections to begin with, and after obtaining the orthographic projections, how we can use the rotation of the line method in order to evaluate the true length of a line as well as the true inclinations of the line with respect to the two reference planes, that is horizontal plane and the vertical plane. So we'll be continuing with further discussion on few more cases in the coming lectures. So thank you very much. Thanks a lot.